Normal variable, percentiles. Session prerequisites, browse to our earlier material on the normal distribution. In preparation, please have the spreadsheet open on your computer and follow along. Maximum benefit guaranteed. Learning objective, calculate the percentile values of a normal variable.
Over to our next question on percentiles. Let's calculate the popular percentiles. These are the quartiles. For this, we will use the norminv function on a spreadsheet. Quartile 1 is given by norm inverse of 0.25, which is the corresponding probability, the mean, comma, standard deviation, giving us minus 0.052. What this means is that 1 in 4 months, you can expect a monthly return dipping below minus 5.2%.
That hurts. Now I know what risk means.
There's something called value at risk, which is hugely relevant to folks in finance. We built an exercise for you around this concept.
Okay, is there a happy side to this?
Sure, we'll look at the third quartile. So for my third quartile, I have norminv of 0.75, the mean and the standard deviation. If our returns were normal, then 1 in 4 months, the monthly returns would cross 9.35%. So I leave it to you as an exercise to show that 23% of our actual returns exceed this amount of 9.35%.
I can live with that.
The catch here is that these returns do not sustain their directions. They go up and down across the months.
Is it a market or an amusement park?
The flip side of question 2 is when we have a specific return and we want to know where it stands.
How about a return of 20%?
That is steep, Lisa. Assuming x is normally distributed, we would want the cumulative probability. We will use normdist once again. Watch me. So I have probability x less than or equal to 20% or 0.2, and that is given by normdist of 0.2, the mean, the standard deviation, and 1 of course for cumulative, and we get 0.9515, meaning nearly 95% of the monthly returns fall below 20%. Remember, we have percent rank to help us with the actual returns. So I have percent rank of 0.2, and that is given by percent rank of array, which is b colon b, and 0.2. And I get 0.941 or 94.1%. Here's an interesting exercise. For each value of the return, figure out 2 things. The predicted percentile for the return, you use normdist for that. The actual standing for the return, you use percent rank for that. Next, compare the two with a scatter plot. If the data set is close to normal, then these two quantiles will be close to each other and the points are scattered about the 45 degrees line. The fancy name for this plot is QQ or quantile-quantile plot. QQ plots are an easy visual check for normality. We can do more with them, like detecting skew in the data. You will see later that normal distributions form the bedrock of statistical inference. For example, they can help someone estimate the average salary of a company's employees based on just a small random sample. It's time you got cracking on those exercises.
Exercises, they're the new normal.
We'll see you again.